This is Geometry, Section 1.5, Exploring Angle Pairs. So to review, we've learned what adjacent angles are. Adjacent angles are two angles that share a side and a vertex, but do not overlap. So two places where we're going to see this a lot are two things called complementary angles and supplementary angles. And we're not really going to use the term adjacent angles that much anymore, but these are two examples of where we see those things a lot. So complementary angles are angles that add up to 90 degrees, and supplementary angles are angles that add up to 180 degrees. So these two things are often adjacent angles. We often see them as adjacent angles. They don't have to be, but 9 times out of 10, they're going to be adjacent angles. So, for example, complete and label the diagram so that angles 1 and 2 are adjacent and complementary. So we just wrote down that complementary means they add up to 90 degrees. So if I want an angle adjacent to angle 1, I'm going to say that this is the common side right here, and that angle 2 is this angle right here, so that those two angles together add up to 90 degrees, or they make a right angle. For 3 and 4, I want them to be adjacent and supplementary, so same thing, I'm going to use this side right here, and I'm going to draw angle 4 like this, so that these two angles are supplementary, meaning they add up to 180 degrees, or we can also write down that they make a straight line. So, given this diagram, and also given that G and Q are complementary to each other, so automatically we know that complementary means they add up to 90 degrees. So if G and Q are complementary, and Q right here is 40 degrees, we know that Q must be that 90 degree total minus 40 degrees. So G would have to be 50 degrees, so that those two angles together add up to 90, since it says they are complementary. Same thing, it says G and F are supplementary, so if G is 50, we know G and F have to add up to 180 degrees, because that's what supplementary means. So 180 minus 50 would give us 130 for F right here. So F is 130, G is 50, and last thing says Z and Q are supplementary, again meaning that they add up to 180 degrees. So Z and Q we already know is 40 degrees, so if Z and Q add up to 180 degrees, we would subtract the 40 we already have from 180, and we would get that Z is 140 degrees. We're not given a diagram this time, however, we're told that P and Q are complementary. When you see that word, you should always think that they add up to 90 degrees. Therefore, it tells us P is 8x minus 1 degrees, and Q is 4x plus 7 degrees. Again, we're adding some algebra in here. We're going to see that a lot. So we know that these two things, these two expressions, should add up to a total of 90. So what we're going to do is just take those two things, 8x minus 1 plus 4x plus 7, add them together, and set them equal to 90, because we know these two things together have to give us a total of 90 degrees. So combine our like terms, 12x, negative 1, and 7 gives us 6 equals 90, subtract the 6, 84 equals 12x, when we divide by 12, we get x equals 7. Now, how do we solve for the measure of angle P and the measure of angle Q? Well, we just solved for x, so we plug that back in to both of these expressions. So for P, we've got 8 times 7 minus 1. 8 times 7 would give us 56, minus 1 would give us that angle P is 55. Now we can either plug 7 back in for our expression for Q, or we can say, I know these two angles are complementary, therefore Q must be the difference between 90 and angle P, which I just found as 55, therefore Q has to be 35. And we would get the same thing if we plugged 7 in for Q in that expression. Two other new concepts. A linear pair is two adjacent angles, using this symbol, meaning angles that make a straight line, hence the term linear pair. So a drawing example of what this would look like is we've got a straight line, and then we cut that line with another ray or segment or something like that, and we create two angles, angle 1 and angle 2. So angle 1 and angle 2 would be considered a linear pair. So our fact that comes out of that would be that the measure of angle 1 plus the measure of angle 2 is 180 degrees, since those two angles make a straight line. They make a linear pair together. Vertical angles, we're going to see this a lot. Vertical angles are two angles that share a vertex, and I'm going to put this in quotes, they make an X, and I'll show you what I mean by that. So the drawing of what this would look like is if I've got one line and then another line intersecting that line, and that creates four angles, 1, 2, 3, 4. So angles 2 and 4 are across from each other. They share a vertex, and together they make this X right here. If I look at it sideways, 1 and 3 also make an X like this. So vertical angles are across from each other, and they share a vertex. And once we do more problems, it'll become clear what vertical angles are. So vertical angles, this is very important. Vertical angles are always congruent. Okay, so based on this diagram, we would know that angle 1 is congruent to angle 3, because those are vertical from each other, and angle 2 is congruent to angle 4. They are across from each other in this diagram. So, using those two concepts, use these diagrams to name pairs of vertical angles and linear pairs. So in this diagram right here, vertical angles, again, we've got two lines intersecting each other. Vertical angles are angles that are across the X from each other. So an example would be angle 1 and angle 3. Another example would be angle 8 and angle 5. They are across from each other. Linear pairs in here, we've got a bunch of them. So angle 1 and angle 8 both make a straight line. Angle 1 and angle 5 also both make a straight line. Then we've got angle 5 and angle 3. And finally we've got angle 3 and angle 8 that also make a straight line. This next one is a little bit more complicated. So vertical angles. So we've got this line right here, this line right here, and then this other ray right here. So if I look at those first two lines, angles 6 and 7 both use those two straight lines, and they are across from each other. So angle 6 and angle 7 would be considered vertical angles. Angle 2 and angle 4 look like maybe they could be vertical angles, but the reason they're not is because this right here is a straight line. However, this side of angle 4 does not make a straight line with this side of angle 2. So that's an important concept to remember with vertical angles. The sides of the angles have to make two straight lines. So I would not be able to make any vertical angle comparisons out of angles 2, 9, and 4, even though they are kind of across from each other. So angles 6 and 7 are the only vertical angles in this diagram. Linear pairs, we've got angle 2 and 7, and angle 2 and angle 6. Jumping down here to the practice problem, so applying what we just learned about vertical angles and linear pairs, we've got to solve for the variables here in this diagram. So if I look at these two angles right here, there's an angle that's 100 degrees, and then this angle right next to it or adjacent to it is labeled 5V degrees. And if I look closely at those angles, I can see that they make a linear pair. They make a straight line together, which means that they have to add up to 180 degrees. So to solve for that variable v, I can say that 100 plus 5v, those two angles must give me 180 degrees total. So I've got this equation here. Now I just solve it. Subtract 100 from both sides. 80 equals 5v. Divide by 5. and I would get that V equals 16. Now, solving for W, now that I know what V is, I could plug this in and figure out how many degrees this angle is right here, and then compare it to 4W, just like I did with 105V, knowing that these are a linear pair. Or I could look at 4W and 100 and say, oh look, those are vertical angles, therefore I know they must be congruent. So we've got to keep straight that vertical angles are congruent and a linear pair adds up to 180 degrees. Those are two different things. So I know these two angles are vertical, therefore they're congruent. So instead of adding them up and setting them equal to something, I'm going to set them equal to each other. So 100 equals 4W, divide by 4 to solve for W, W equals 25. Same thing over here. I'm going to solve for A first, since I have A here and A here, and then I've got a C here. So I'm going to hold off on that until I solve for A by relating these two angles right here. So we can see again, these make an X, therefore they're vertical angles. So I can set them equal to each other. Get all my A's on one side. Divide by 3. A would equal 10. Now that I know A equals 10, I can plug it back into one of these. So 8 times 10 minus 4, 80 minus 4 would give me 76 degrees right here. Now I know that 13C makes a linear pair with either one of these two vertical angles right here. So I can compare that. I know that 76 plus 13C, like I said, they make a linear pair, so they would have to add up to 180. Switch colors and rewrite this down here. So 76 plus 13C equals 180. Subtract the 76. 104 equals 13C, and when I do my final step of dividing by 13, I would get that C equals 8. Last concept, so an angle bisector. An angle bisector is basically anything that cuts an angle in half. So we've talked about the term bisector before, so this is the angle bisector. AN is the angle bisector of this angle CAT right here. And to mark that angles are congruent, we're going to use what we call a rainbow mark. So to mark segments congruent, we use tick marks or hash marks. We're going to make a little curved mark on these two angles, showing that those are congruent to each other. So again, an angle bisector is just a ray that divides an angle in half. So using that concept, given that AF is an angle bisector of TAN, so this angle right here, meaning that these two pieces are congruent to each other, solve for angle FAT and angle FAN. Now this is a little bit complicated because we don't have much to go on except that we've got this 70-degree angle right here. We know these two angles are congruent to each other, but we don't know what they are. So we're going to call them each X. If I look at these three angles together, I see that they make a straight line. Therefore, those three things must add up to 180 degrees. So I'm going to add them all up, set them equal to 180. If I combine X and X, I get 2X, 180. Continue solving my equation. So X would equal 55 degrees. Therefore, each of these angles would equal 55 degrees. Last one. ON bisects angle DOT. Therefore, I know these two angles are the big angle cut in half. Therefore, again, they must be congruent to each other. So just take those two expressions and set them equal. Get all your y's on one side. Y plus 10, 20, subtract the 10, I would get that y equals 10. To figure out what each angle is, so TON would be this angle right here. Plug that in. 40 plus 10 would give me 50. I know I've got an angle bisector, therefore the other angle must equal the same thing, because an angle bisector creates two congruent pieces, so both of these have to equal 50, and then the entire angle together would equal 50 plus 50, or 100 degrees.